Hi, kids. All right, so again, we have a moving box. This time, a moving box is going to hit a spring, and then it's going to compress the spring. I said just made up a number, 0.5 meters before it stops. If the box was moving twice as fast, how far would the spring compress? Okay, so this way I'm going to do it actually opposite of the last one. Last one where I started with kind of like, okay, let's think it through and solve it. This way I'll make up the numbers first. We'll solve it, and then I'll show you how we could have just kind of thought it through. Okay, so you should be thinking, okay, let's say, again, we had this problem. So a moving box. So again, right away you should be thinking, okay, moving. Okay, so anytime we're doing a spring, you should be thinking energy. So you should be thinking moving box, oh, that's kinetic energy. So if I go, okay, at the start, here is my box moving at the start, and there's my spring. Okay, so at the start, what type of energy do I have? Oh yeah, I just have kinetic. I only have kinetic energy, and then later on, my spring gets compressed. Okay, if it stops moving, what type of energy do I have? Oh yeah, I have potential. So then you can say, well, I know my kinetic has to end up equaling my potential. So if I say that equals one another, I end up with 1/2 mv squared equals 1/2 kx squared. Okay, and right away, if you're kind of thinking about the other, just think it through way, you probably can kind of have an idea. But again, I'm going to do the math way first, where we make up numbers. So you say, okay, so here's what I have. Okay, so I'm starting with this, so it doesn't give me a mass, so guess what? Make up a mass, okay? Again, really easy mass is 1 kilogram. I don't have a speed, so I'm going to make up a speed. Really easy speed is 1, so I end up with 0.5 joules. And then on this side, I'm going to get 1/2 k times 0.4 squared. And now I can solve this for k. So if I do this, divided by 1 divided by 0.4 squared is 6.25. Okay, so my k is 6.25 newtons per meter, because remember that's the units for k. So then now, okay, so then I said, okay, now I'm going to do the same problem, except I'm going to double my speed. So I'm going to say, okay, 1/2, and my mass is still 1, but instead of 1 for my speed, I'm going to get 2 squared equals 1/2. I know it's k, 6.25, and then I want to solve for x. Okay, so if I do this, okay, 4, 2, so this is 2 joules equals this mess, so 4 divided by 6.25, take the square root, and I get 0.8. Okay, so I have my x equals 0.8 meters, and you go, oh, that's double that. Okay, which is the final answer anyway, and you could have kind of thought that through just by going, okay, if you look, well, this is a square relationship, this is also a square relationship, so it's going to end up being a 1-to-1 thing, which is why if I double the speed, it compresses twice as much. But my point again is I'm trying to show you guys, if you're like, I don't really know how to do it, make up numbers and solve it. Okay, bye kids.